In the year 1897, a fisherman off the coast of Japan pulled something out of the water that made him drop his net and step backward. It was pink. Not fish pink bubblegum pink, with skin so thin you could see the blood moving underneath it. Its snout was long, flat, and blade-like, jutting out from its face like something had been grafted on wrong. And when it opened its mouth to gasp for air, its jaw didn't just drop, it launched forward, out of its own skull. Like an alien mouth from a movie, the entire jaw shot out on what looked like a spring-loaded hinge, snapped closed around nothing, and slid back into place, all in about 1/10 of a second. Faster than you can blink. The fisherman had just caught the first goblin shark anyone had ever properly examined. And more than 125 years later, we still don't fully understand how something this strange is still alive today. This is the goblin shark, and nothing about it is normal. Let's start with the single strangest fact about the goblin shark, because it reframes everything else about this animal. It isn't just an old species. It's a living fossil. The goblin shark's lineage, the family Mitsukurinidae, stretches back roughly 125 million years, into the early Cretaceous period. For context, that means the ancestors of this shark were swimming in Earth's oceans, while Tyrannosaurus rex's ancestors were still small, unremarkable dinosaurs. Goblin sharks were already old news by the time the most famous predator in history showed up. And somehow, through an asteroid impact that wiped out 3/4 of all species on the planet, through multiple ice ages, through millions of years of ocean chemistry changing again and again, this exact bizarre body plan survived, almost unchanged. Modern goblin sharks look almost identical to fossilized relatives from tens of millions of years ago, while other shark families evolved, specialized, and diversified into hundreds of different hunting strategies. Goblin sharks basically looked at evolution and said, "No thanks, I'm good." So why? Why would an animal stop evolving when almost everything else around it kept changing? The answer is where things start to get uncomfortable, because it's hiding somewhere that nothing can reach it. Goblin sharks live deep. Not deep like scuba divers go, deep like commercial submarines struggle to get to. Confirmed sightings and captures place them anywhere from about 300 feet down to over 4,000 feet a zone, so dark that sunlight has never once touched it in the history of the planet. Down there, there's no sunlight, which means there's barely any plant life, which means there's very little pressure for an animal to improve. If your hiding spot is a place literally nothing can find you, why would you need to change? Evolution doesn't reward being better. It rewards being good enough to survive. And for 125 million years, the goblin shark's answer to survival has simply been disappear into the dark and don't come back up. Which raises an obvious question. If it lives that deep, and we've barely explored that deep, how do we even know it's still down there? Here's where the goblin shark breaks its own logic. Every other deep-sea predator has figured out the same trick. Be invisible. In a world without light, most deep-sea animals are jet black or deep red, because red light doesn't travel far enough at depth to be seen, meaning a red animal is functionally invisible in the deep ocean. Anglerfish, dragonfish, gulper eels, almost everything down there is either black, deep red, or transparent. The goblin shark didn't get that memo. It's pink, bright, almost cartoonish pink, the color of the inside of your mouth. And the reason isn't pigment at all. Goblin sharks don't actually have pink skin. Their skin is nearly translucent, so thin that you're not looking at skin color, you're looking straight through the skin at the blood vessels underneath. The color is coming from inside the animal, which means, in a place where camouflage is a matter of life or death, the goblin shark is functionally see-through, and it doesn't seem to care. So how does an animal that's basically wearing a neon sign survive at all? The answer is that it stopped playing the hide from predators game and started playing a completely different one. It doesn't need color-based camouflage because almost nothing hunts it in the first place. At those depths, few predators are big enough, fast enough, or interested enough to bother with a goblin shark, and the ones that could, like larger sharks, rarely descend that deep in the first place. The goblin shark essentially found a loophole. It didn't out-evolve its predators. It moved somewhere its predators mostly don't go. But if it's not hiding from predators, that leaves one huge unanswered question. How does something with terrible eyesight, living in total darkness, actually catch food? That's where things go from strange to genuinely unsettling. Look at a goblin shark's face, and the first thing you notice is that long, flat, blade-shaped snout, technically called a rostrum, sticking out well past its mouth like a paddle. For over a century, nobody was entirely sure what it was for. Some early scientists guessed it was used to dig through sand for prey, like a plow. Others thought it might be for balance while swimming. The real answer is stranger than either. The rostrum is a sensory organ. It's packed with thousands of tiny jelly-filled pores called ampullae of Lorenzini, the same electroreceptor system that hammerhead sharks and great whites use, except the goblin shark's version is unusually dense, especially concentrated along that long, flat snout. These pores can detect the faint electrical fields that every living animal generates just by having a beating heart and firing muscles. In a place with zero light, a goblin shark doesn't need to see its prey. It can feel the electricity coming off a fish's muscles from several feet away, in complete darkness, the same way you might feel heat radiating off a stove without touching it. So picture it, a nearly blind, slow-moving, pink, see-through shark, drifting through pitch-black water, using its face like a metal detector, silently zeroing in on the electrical signature of a fish that has absolutely no idea it's being hunted. And then, the moment it locks onto a target, the goblin shark does the thing that made that fisherman in 1897 drop his net. Most sharks have to swim forward and bite down to catch prey. It's a whole-body commitment: speed, angle, timing. The goblin shark skips almost all of that. Its jaw is attached to its skull with unusually long, elastic ligaments, essentially built like a slingshot. When it's close enough to a target, it doesn't lunge with its whole body. It fires its jaw alone forward, out of its face, extending it nearly the full length of its snout in a fraction of a second, and snaps it shut around the prey before yanking it back into its mouth. Researchers who've studied this mechanism have clocked it as one of the fastest bite mechanisms recorded in any shark. Some estimates put the strike at under 1/10 of a second, faster than the human eye can properly track without slow-motion footage. It's essentially evolved a face that functions like a mousetrap. It doesn't chase prey, it waits in the dark, feels the electricity of something swimming nearby, and launches its own mouth at it. And once that jaw makes contact, the goblin shark's teeth finish the job, and those teeth tell their own story. Up front, the goblin shark has long, thin, needle-like teeth, almost like nails, perfect for snagging soft-bodied prey like fish and squid, and making sure it can't wriggle free. Further back in its mouth, the teeth flatten out into broader, crushing plates, built for grinding down harder prey like crustaceans. In other words, this is an animal built almost entirely around one single strategy: sense the electricity, launch the jaw, grab with the front teeth, crush with the back teeth. It's not a fast swimmer. It's not a powerful swimmer. Its entire survival plan is, let the ambush do the work. Which brings up the next uncomfortable question. If this animal is such an efficient predator, why do scientists barely ever see one alive? Here's the part of the goblin shark story that almost nobody talks about, and it's honestly the most human part of it. Despite over a century of knowing this animal exists, we have almost no footage of a goblin shark behaving naturally in the wild. Nearly everything we know comes from accidental catches, fishing boats trawling in deep water, who pull one up completely by accident, usually as unwanted bycatch while fishing for something else entirely. And when that happens, the goblin shark almost never survives long. Its entire body is built for one very specific environment: crushing pressure, freezing cold, and total darkness. Its muscles are soft and weak compared to a fast-swimming predator like a mako or a great white, because down in the deep, it doesn't need explosive muscle, it needs almost none, since it ambushes rather than chases. Its skeleton is lightly built. Its metabolism runs slow, adapted to a place with very little food and very little reason to move fast. The second it's dragged up toward the surface, Everything that let it survive in the deep ocean becomes a liability. The pressure change alone can be catastrophic for a body engineered for the crushing weight of deep water. The temperature shift from near freezing to surface warmth puts its whole system into shock. And a body built around slow, minimal movement simply isn't equipped to handle the trauma of being hauled up in a net. Most goblin sharks that are accidentally caught die within hours of being brought to the surface. Some die in transit before they're even fully examined. This is, honestly, the tragic irony at the center of this entire animal's story. The same extreme adaptation that let it survive completely unchanged for 125 million years, total commitment to one dark, crushing, cold environment, is exactly what makes it almost impossible for us to study it alive. We've built submarines that can survive those depths. We've sent cameras down into the goblin shark's world, and in over a century of searching, we've captured only a small handful of genuine video sightings of a live goblin shark behaving naturally in its own habitat. Think about that. We have significantly more footage of some species that live literally at the bottom of the deepest trenches on Earth than we do of an animal that first got named and described back in the 1800s. Which means, in a very real sense, we've known this animal exists for well over a century, and it is still one of the most mysterious sharks on the planet. Quick detour, because the goblin shark's origin story is almost as strange as the animal itself. When that first specimen was caught off the coast of Japan in 1897, it eventually made its way to a marine dealer named Alan Austin, who recognized it as something scientists needed to see. It was formally described the following year by ichthyologist David Starr Jordan, who gave the genus the name Mitsukurina, honoring Japanese zoologist Kakichi Mitsukuri, who helped bring the specimen to scientific attention. But goblin shark, the name that stuck in popular use, actually comes from a Japanese folklore translation. The Japanese name for the animal, tenguzame, references the tengu, a supernatural creature, from Japanese mythology, known for its long, prominent, exaggerated nose. Fishermen looked at that strange flat snout and immediately thought of the same folklore creature, and the English translation eventually became goblin. So this fish has been unsettling people for so long that the first instinct humans had upon seeing one before we even had modern marine biology to explain it was to reach for folklore. Before science had an explanation for the face, mythology already had a word for it. And honestly, once you understand what it actually does, the invisible electric sensing snout, the jaw that fires out of its own skull, the folklore comparison starts to make a strange kind of sense. Here's the bigger picture, and it's worth sitting with for a second. The goblin shark isn't rare because it's endangered in the traditional sense. As far as we can tell, it's simply been doing exactly what it's always done, in a part of the ocean we've barely touched. It's not clinging to survival. It's thriving, quietly, in the dark, using a hunting method that's remained functionally unbeaten for over 100 million years. We tend to think of evolution as a race bigger, faster, smarter, always moving forward. The goblin shark is the counter-argument. It found one strategy that worked in one specific extreme environment, and instead of continuing to change, it simply committed, completely, for longer than most animal families have even existed. And the deep ocean is full of the same lesson, over and over, if we bother to look. We've mapped more of the surface of Mars than we have of Earth's deep-sea floor. Every single time a research vessel drops a camera into water deeper than about 3,000 feet, there's a real chance of documenting something never recorded on film before. The goblin shark isn't a monster. It's not a mistake. It's a reminder that the ocean has had 125 million more years than us to work out its own answers, and we've only just started asking the questions. So the next time someone tells you the ocean has already been fully explored, that we've found everything down there worth finding, remember the goblin shark, an animal that's been swimming around, completely unbothered, since before most dinosaurs existed. An animal we've known about for over a century and still barely have footage of. An animal with a face built like a weapon and a body built to disappear into a world we can barely reach. If something that strange can stay hidden for this long, in an ocean we've spent decades exploring, what else is still down there waiting? If you want to see what happens when things get even deeper, that's where I'd go next. Because if you thought this was strange, you have no idea what's underneath it.